Today we're going to take a look at compound interest. In general, compound interest is when we take the interest that we accumulate and we add it to our principal amount being how much we started with at the beginning. So we take our compounded interest or accumulated interest and we compound it with the amount that we start with, our principal, and then we start generating interest on top of it. So whenever you have an investment, the more often you compound, the better your investment's going to be over a certain amount of time. So if we take a look at this formula, let's start with A of t. A of t means the amount over a certain period of time, whether it's 1 year, 10 years, whatever that time period is. The P is our principal. So that's how much we start with. And then in our parentheses, we have 1 plus, and we'll talk about that in a second. R over N. R is our interest rate. N is our number of times it's compounding per year. So if it compounds annually, we compound once a year. So the interest doesn't go into that principal until the end of the year, and then we can start accumulating interest on top of the interest after that year's over. And then the T is number of years. Okay. So let's talk about the equation in general before we start talking about the compound interest part. So we have our general, and actually let me change that to an f of x. So we have our general function for an exponential growth or decay situation. We have f of x equals ab to the x power. A of t is no different than f of x. It just means amount instead of the just arbitrary f. P is our initial amount, which is A. We talked about before. A was our initial amount. And B is my multiplier. And we know with the multiplier, we always start with 100%. So if you look at your equation up here, we have 1. And if I have 100%, if I move my decimal point 2 times, is equal to 1. So I'm taking 100% plus whatever my interest rate is and dividing it by how many times per year. So interest rate divided by how many times per year. So that gives me my B value. And then X is number of time periods. So if it compounds annually, N in my formula up here would be equal to 1, and I multiply it times how many years. So if it's 10 years, once per year, it'd be 10 times. Now if it compounds quarterly meaning 4 times per year, N would be equal to 4, T would still be equal to 10 because it's 10 years, but it would compound 40 times, 4 times every year for 10 years. All right, let's now take this equation and create a problem situation where you can actually see the interest compounding. So my first situation, we're going to have $100. We're going to take that $100, we're going to invest it at a rate of 5% over the course of 10 years, and it's going to compound annually. Okay, so once per year, it's going to take the interest, it's going to put it in with the principal, and then the next year, you'll gain interest on top of your interest. So let's take our equation. A of t, so we have amount after 10 years is equal to the principal amount of 100 times 100% plus the 5%, so we're growing at 5% once a year, to the 1 times 10, because once a year times 10. Now, you could put this all in your calculator and get the final amount, but what you need to do if you're going to do that is you need to make sure you put parentheses around your exponent. Otherwise, it'll take this set of parentheses to the first power and then multiply your answer times 10, and we don't want that to happen. So make sure you put those brackets or parentheses around your exponent. So whenever I enter that into the calculator to get the final amount of my investment, I end up with $162.89. Okay, so after 10 years at 5% per year, compounding once a year, I end up with $162.89. Okay, so let's look at another problem situation. So we're going to start off with the same investment. It's still $100. I still have 5% per year. Still going to look at 10 years. However, this time, I want to compound quarterly. Interest is going to compound 4 times a year. So after the first 3 months of the year, we're going to take the interest, put it into the account with the principal, and then the second quarter, we're going to start generating interest off of that. So if we set up our equation again, so we have A of 10, so the amount after 10 years, starting with $100, 100% plus our 5%. Now this time my end value is equal to 4. So I have to divide that 5% up among 4 time periods so that I get 5% over the course of a year. And then we have 4 times 10 years. So the number of time periods we're talking about now over 10 years is 40, because each year has 4 of those quarters. And again, I'm going to put brackets around or parentheses around my exponent. And then I'm going to calculate the amount of interest, not the amount of interest, but the amount of money I'm going to have after 10 years. And this time I'm going to have $164.36. And the last example I'm going to look at, same situation again, but we're going to compound a little more often. So we have $100, 5%, 10 years, and we're going to compound daily. So every day we're going to take our interest, we're going to put it into the account with the principal and the other interest that's already there, and then the next day I'm going to generate interest on top of all of that. So I have the amount after 10 years equals 100, 100% plus 5% again. This time I'm going to divvy that 5% up among all 365 days to the 365 times 10 power. And again, putting my parentheses around my exponent. Okay, and if I compound daily, I would end up with a total of $164.87. Now, the difference between the 3 accounts isn't overly dramatic in terms of the amount of money, but if you were to invest a lot more money, instead of $100, you invest $1 million, you would see that the differences would be more significant. Percentage-wise, it would still be the same. But in terms of amount of money, $100 isn't that big of an investment. Okay, so the more you compound, the more money you're going to make in the end, regardless of whether it's a lot or a little.